whole numbers. Where does tangent have whole numbers at? What kind of whole numbers do you get for 0 and, right, and -1? So there's three numbers that we need. Where is tangent 0 at? Remember, it's sine over cosine. It's the side. The sides are where they're 1, where they're 0. The top and the bottom is where they're undefined. Where are they positive 1? What does tangent equal a positive 1? Say again? Oh, there's one of them. There's two spots actually where tangent is 1. Pi over 4, very good. Remember, pi over 4 is where x and y equal the same thing. There's one more place where x and y equal the same thing. Yeah, very good. So there's your positive ones. Over in that quadrant is your negative ones. Good. So, one more time. Where is tangent undefined? On the top and bottom. On the y-axis. So, tangent can only function on that side or on that side. That's it. Tangent can't go all the way around because of it being undefined right here. So if a regular circle has a circumference of 2 pi, what kind of circumference am I only going to get for a tangent? What's half of 2 pi? Right. So if I graphed this stuff on Desmos, it would start repeating pi radians after pi radians after pi radians, which is not the case for cosine and sine. Sine repeats after 2 pi, and so does cosine. So let's talk about cotangent. Let's pretend this is cotangent. So remember, cotangent, I guess I shouldn't do it like that. Cotangent, where would cotangent be undefined? No, that's tangent. Tangent's undefined here. Where's cotangent? The sides. Good. Sorry, my nose is running. So look at the top and bottom. Y'all, the top and bottom are halves. So tangent is always undefined on halves. Always. Cotangent is always undefined on whole numbers. 2 pi, 0 pi, regular pi. Sorry. Now, since it's undefined right here for cotangent, then what's its period? It's blocked off too. It's still either this side and go from here to here, no problem, or I go from here to here, no problem, I got it. So, with that being said, the rules change for today. So, if you could please go ahead and open your packet to page 17. Excuse me, I have no idea what happened. All right, so here's what's going on page 17. We're going to graph tangent and we're going to graph cotangent. And I am so lucky that I broke my packet in half because I get to look at things side by side. Well, you guys do too, the way it was formatted, so that's good. All right, so remember, over here for tangent, we just talked about it, tangent is undefined at these points, which means we have automatic asymptotes. There's automatic asymptotes that are happening right there. And remember, cotangent is undefined on the hole marks. Oh, hi. We have automatic asymptotes for cotangent also. Now, one more thing that's not on here, but are critical points. What's tangent for pi over 4 again? And also this one, which is 5 pi over 4. Now look, let's go to tangent, or let's go to cotangent. If I tried to start right here and talk about cotangent, I'd be stuck because I can't go up because it's undefined at 0. Let me go down. Remember, if you go down, it's negative radians. Where does that equal for negative pi over 4? It's a 1. It is, but think about like the x and y coordinate. What kind of 1 is it? It's negative. So that's negative pi over 4, 2 pi over 4. Here's negative 3 pi over 4. So over here, cotangent equals negative 1. Oh, goodness. Over here, cotangent equals, what does it equal, y'all? I'm sorry. Positive 1, yeah. All students take calculus. All right, so since you have asymptotes, you don't have waves. There's no such thing as a tangent wave. There's a cosine wave, there's a sine wave. Tangent waves don't exist because it got blocked off. So the way this is going to look, tangent is going to have a wavelength like that. Cotangent, remember cotangent got all messed up because it was blocked off at 0 at the beginning. So cotangent looks like that. What's the difference? Look at the arrows matter. Tangent's always up on the right. You should probably write that. And what do I mean when I say up on the right? The right-hand arrow of the wavelength, it's always pointing up. But not cotangent. Cotangent's always down on the right. Okay. So we're going to look at the parent function. We're just going to look at these guys together. All right, listen, I really want this to be side by side like this, but your job is to tell me when you can't see. I really need you to see, but I really want to show you guys side by side. Please let me know if you cannot see, and then we'll go to a single page view. I'm going to focus on tangent right now. What do I know about tangent? I know that it is never going to have anything at positive pi over 2. I know it's never going to have anything at the bottom of the circle. If I go in the positive direction, the bottom of the circle is definitely 3 pi over 2, for sure. Those are asymptotes. What if I go clockwise? What if I go clockwise? I would be at, well, it's the bottom of the circle, but when you go clockwise, it's just negative pi over 2. How far apart are these lines? How far apart is it from 1/2 to 3 over 2? 2 pi over, and what does that simplify to? Pi. That's the half circle. They're all that far apart. So the period, look, the period changes now. We don't take 2 pi and divide it by the reciprocal of b because we can't go all the way around the circle. 2 pi is gone. It's regular pi. I can't go all the way around the circle. All right, so these are pi lengths apart because pi is the period. Now remember, we know we had tangent of 0 somewhere. We talked about tangent having a positive 1 somewhere. We also talked about where tangent had a negative 1 somewhere. Where does tangent equal 0 again? Say again? Left and right, which is, it's off my screen, which is 0 pi, 2 pi, and regular pi. So all the halfway marks, I'm sorry, all the whole numbers, it equals 0. So look, input, output, that's the origin. And then if you go all the way back around the circle, remember, it is also going to cross at the whole number of 2 pi. All your whole numbers is where tangent equals 0. That's just pi. Sorry, guys. That's the left and the right. All right, where did tangent have a value of 1 again? Pi over 4, good. Look, what's halfway in between 0 and a half? A fourth. And that's where it equaled positive 1. I'm going to draw a dot there. Look how I did that. What's halfway in between a negative half and 0? Negative pi over 4. Negative fourth. So look, if I went negative fourth down, remember that value's negative 1 because the x and the y's are opposite signs, which is, let's say negative 1's right here. This is why that graph makes that shape. This is why it's up on the right, because it was at positive 1 up here. It's at negative 1 over here. When I ask you to graph tangent and cotangent, I need to see 2 shapes. So your other shape is just going to match it. Now look, I'm going to show this part, but you don't have to show this every time because it is what it is. All right, let's go ahead. Let me go ahead and just zoom in over here on tangent for a moment. All right, so here's the deal. Let's talk about the A value. The A value is just 1. By the way, you can't call that amplitude because only waves have amplitudes. Remember, that's not a wave. Its vertical stretch is 1. Its B value is understood to be 1. It doesn't have an HK. I mean, we can call it, look, I'm going to abbreviate. Remember phase shift from yesterday's homework? Phase shift is the same thing as horizontal. The phase shift is 0. The K value is 0. Remember, the K value was the midline yesterday. It's still the midline. So here's the middle. Here's where the graph equals 0. In the middle is where tangent equals 0. Remember, we had a vertical stretch understood to be a positive 1. So if I go up 1, that top line is where the graph has an output of 1. One place below the midline is where the graph has a value of negative 1. So all of that ties in, but I am not going to ask you to write all of this on here. Here's what I'm going to show you. I'm going to show you what we're going to write for tangent and cotangent on plane cotangent. All right, let's shift gears and let's talk about cotangent. Remember, cotangent is crazy from the beginning because it got blocked off on the y-axis. Let's block it off. Remember, it's impossible where x equals 0. So it never had a chance to be normal because it never got to start at 0. That's how I think about it anyway. All right. So remember, it only has a period of pi because it would be undefined if it tried to go entire circle. So let's write pi and then negative pi over here. Okay, now, where does cotangent equal 0? Cotangent of what equals 0? Say again? At the top and bottom, which is pi over 2. Look, what's halfway in between 0 and a full pi? Pi over 2. What's in between these two? Negative pi over 2. Let's draw a dot, because that's the place where tangent equals 0. Now look over here, y'all, I'm on the negative side. So if I tried to figure out like where positive 1 is and negative 1 is, I have to go clockwise because I'm on the other side, I'm on the negative side. So if I go down to negative pi over 4, that is going to be underneath, guys. So negative pi over 4 is going to be also thinking about this negative 3 pi over 4. What is negative 3 pi over 4? It's a positive 1. See how it's negative 3 pi over 4? 3/4 is in between a whole and a half. This is negative 3 pi over 4. It's a positive 1. Now remember, I'm on the negative side, so I have to go down. What about this negative pi over 4? What does that give you? Negative 1. Because the x and the y coordinates are opposite signs. That is why this graph is down on the right, because it got shifted over. So look, guys, the other side looks like this. All right, one more example, and then we'll move on back to tangent. But real quick, guys, look, we have cotangent. Let's talk about this for a moment. I just want to focus on like the horizontal stuff that's happening. Horizontal is a phase shift and a B value. That's the stuff that messes with the sideways movement. What's the phase shift? Pi over 4, positive pi over 4. It's just h. Remember, it's just h. It's going to be positive pi over 4. That totally messed up the graph for cotangent, so it's not going to start at 0 anymore because of that. Do we have a b value? We do. It's right there. It's 2. So all of that stuff is going to mess up the parent function asymptotes. So where's the asymptotes going to be? Let me show you. You're going to take all this craziness and you're going to set it equal to where cotangent couldn't happen. Remember, cotangent's so weird because it never could happen at 0. Look right above, it's off my screen, but look at what you drew. You drew an asymptote at x equals 0 on the parent function. If I solved for x, what would be my method for solving for x? What would I do with this? Yeah, but yeah, that's 0. What's anything? Like, what is that going to be over here still? What does x equal? Your first asymptote for cotangent is always the phase shift, because it's always moving from 0. Okay, let's draw that real quick. Let's draw pi over 4. Phase shift, boom, always the first asymptote for a cotangent. That's an asymptote. Remember, everything happens in periods. There's an asymptote over here. There's an asymptote over there, for sure, no doubt about it. X equals, but I don't know. I don't know what they are, because this messed up the period. These aren't pi places apart anymore. That messed it all up. So we're going to take pi and multiply by the reciprocal of b. So what's a period? A half, yeah. So if this is pi over 4, this space right here is pi over 2. So pi over 4 plus pi over 2 is going to be that. So remember, think about that being 2 over 4, because that's a half. 2 over 4 plus 1 over 4 is, yeah, that's our other one. So remember, that's 2 over 4, but we need to go in the negative direction. So what's 1 over 4 minus 2 over 4? Yeah, that's your other one. What's your midline? Ooh, I didn't write that down. You're going to have to come up with a midline all by yourself. What's the midline? It is. It's just the k value. You don't have to draw a dashed line. Let's just kind of estimate where the 3 is. 3 places above the origin. Y'all, this is where the graph takes the turn. The midline is where the graph takes the turn. Now look, what's halfway in between these two? If that's a negative 1, if that's a negative 1 and that's a positive 1, what's right in the middle? There's your first branch. We got to find the middle in between these two. What's halfway in between 1 over 4 and 3 over 4? Pi over 2, that's your other one. That's all I need. That's all I need. That's it. Okay, look. Let's see what's going on here. Let's look at number 4. Take a deep breath. Wipe the drool off your chin. This is the last one we're going to do. This is it. All right, look. What does all this stuff mean? Remember, 4 is a vertical stretch. There's no such thing as the amplitude because it doesn't make waves. 3 is the B value. That's totally going to affect your period. So our period's all messed up. Phase shift is negative pi over 6. Now remember, tangent wasn't blocked off at 0, so keep that in your head. The phase shift is not your first asymptote. That's only for cotangent. We have a midline. The k is negative 2. And then again, guys, I'm just going to remind myself what this shape looks like because I'm not showing a lot of points on this. All right, so remember your original tangent had an original asymptote of that. But y'all, this pi over 6 messed it up. This horizontal compression messed it up. So we have to figure out where the first asymptote is. So you're going to take all that and set it equal to the original asymptote. just for clarity, why am I not messing with the -2? Because that's up and down movement. That doesn't mess around with what's happening on this sideways stuff. Why am I not worried about the 4? That's up and down stuff. I'm not worried about that. I'm only worried about sideways stuff. So your horizontal compression and your phase shift. All right. Ooh, we got to solve for x. That is not going to equal 0. We're going to multiply both sides by the reciprocal. So x plus pi over 6 equals pi over 6. So what does x equal? Yeah. That's your first asymptote. Let's go ahead and block that out. You got another one over here. You sure do. I don't know what it is, though. You got one over here. For sure. I don't know what it is, though. How are you going to figure that out? The period. All right, so remember, the period is going to be regular pi times the reciprocal of b, and that's going to give us our brand new period. Y'all, how far apart are these? That much? What does this equal? Pi over 3? Yes, yes, yes. What does this equal? Yes, negative pi over 3. Okay, look. You got two important things, then we're going to draw our wave, and then you're going to be done. We know our midline is at -2. Okay. I'm going to draw a dot right here because that's where tangent equals 0. That's, if we plug that in, we would have an output of 0 right here. But I do need to know these. Like, I don't know. What are those? What are those x values? Whatever halfway in between 0 and pi over 3 is. What's half of pi over 3? I don't know. Let's just do the math. What's that? Pi over 6. What's this one going to be? Yeah. That's all you need to show on there. Just draw your waves. Remember, it's tangent. So your arrows have to be up on that side. That's all you have to draw. But guys, just remember this vertical stretch, this 4. If I went 4 places down right here, you don't have to draw this, at -6, that's where the output's -1. If I went 4 places above this at 2, that's where the output's +1. And that's it.